Hello. Okay, so this is a little mini review for lesson 25, Pythagorean theorem, distance in a coordinate plane. Before we get started on this one, I want to make sure that you have the information you need about Pythagorean theorem and about Pythagorean triples. So I always like flashcards. If you find that your flashcard works for you, then go ahead and pause the video at any time and put it in your notes or make a card. Things that you need to remember about Pythagorean theorem is, first of all, it works only for right angles, so triangles. So we need to make sure that the triangle that we're working with is a right triangle. Otherwise, Pythagorean theorem does not work. The second thing that you want to do is make sure that you can label your right triangle correctly. Notice that I have A and B as the legs, and I have C as the hypotenuse. Now we can remember the hypotenuse in two different ways. First of all, it is the longest side of the triangle. And second, it is the opposite of the right angle. So notice my right angle is right here. The hypotenuse is always opposite of it. So if it helps to draw an arrow because the right angle is pointing to the hypotenuse. Now, the cool thing about the legs is because A squared plus B squared, since this is addition, we can use commutative property. That means I can name this leg B and this leg A if I want to. So I've written down here that A and B can be named interchangeably. Yes, it got kind of blurred at the end, but that means I can actually change A and B. They don't have to be in this exact order. As long as the two legs are A and B, you're good. But you cannot confuse C with A or B because then the Pythagorean theorem does not work. C always has to be the hypotenuse, and it always has to be on this side of the equal sign. Okay, now that we've got Pythagorean theorem, let's go ahead and look at Pythagorean triples. Now, Pythagorean triples are really cool because once you see the pattern, sometimes you can figure out the problem without actually having to solve. Let me zoom in a little bit here. Okay, so Pythagorean triples are whole number side lengths that work for A squared plus B squared equals A squared plus B squared equals C squared. So for example, if I have a right triangle and the side lengths are 3, 4, and 5, then I know that 5 is the hypotenuse, 3 and 4 are the legs. When I actually do the work for this, and if you want to see that, so if I take A squared plus B squared equals C squared, then I can plug in 3 squared plus 4 squared equals 5 squared. That would equal 9 plus 16 is the same thing as 25. And yes, 9 plus 16 is 25. This works. So our lengths of 3, 4, and 5 are whole numbers that do work for A squared plus B squared equals, I did that again, A squared plus B squared equals C squared. Now, there are certain Pythagorean triples that are very, very common. And you'll notice here I have 5, 12, and 13. Those work in Pythagorean theorem. 8, 15, and 17 also work Pythagorean triple, and 7, 24, and 25 are also considered a Pythagorean triple. Now, what's really cool about the triples is you can actually see more Pythagorean theorem triples using these. So if I take 3, 4, and 5, and I multiply all the digits, all the side lengths by the same number. So if I multiply 3, 4, and 5 all by 2, I get 6, 8, 10. And when I plug them in, then I also, so A squared plus B squared equals C squared. I'm going to plug in 6, 8, and 10. And you're going to notice that we get 36 plus 64 equals 100. And 36 and 64 is 100. So if you can recognize that 6, 8, and 10 are a multiple of 3, 4, and 5, then you can use that to solve your Pythagorean theorem problem. Now, that works for all of these. So if I take my 5, 12, and 13 and multiply all the digits by 2, I could also make a Pythagorean triple out of 10, 24, and 26. Same for 8, 15, and 17. If I multiply everything by 2, I can make a Pythagorean triple of 16, 30, 34. And I know it's going to work because the original triple also works. Now, you don't just have to multiply by 2. You can actually multiply by anything. So if I take my 3, 4, 5, and I multiply all the digits by 3, then I get side lengths of 9, 12, and 15. And if we plug them in, it would also work. If you feel like you want to check that out, then go ahead and do that. So what's really cool about Pythagorean triples is once you notice the pattern, the multiples of the triple also work, and sometimes that helps you solve your problem a little bit faster. Okay, so we're going to use those two ideas to go ahead and start working on lesson 25. Now, today I'm going to work on, in this video, just page 253 and 254. Once I get done with that one, we'll move on. Now, I noticed that there are a lot of word problems on this one. When I'm working on word problems, there are two things that I always do for Pythagorean theorem. First of all, I always read the problem at least twice. Just make sure you know what's going on. Make sure you pull out the numbers. Make sure you know what question they're asking. Then I always draw a picture and label it. Pythagorean theorem really does have a lot of pictures, and you need to visually see what's going on. Okay, so what they did here is they actually solved a word problem. They've done both parts. It says a wire stretches from the top of a 20-foot pole to the ground. Now, since they've already drawn the picture, I'm just going to take each sentence and look at where it is in the picture. A wire stretches from the top of a 20-foot pole to the ground. So notice here's my pole and here's my 20 feet. So my picture is already labeled. The wire is secured to the ground 15 feet from the base of the pole. That's important, from the base of the pole. So they've taken the wire, they've secured it to the ground right here, and it's 15 feet from the pole. So that's why they've labeled it 15 feet. So now they'd like to know, what is the length of this wire? So if we take a look at what we know about Pythagorean theorem, we know that we have a right angle here. The two sides of the triangle that are touching the right angle are the legs. So we do know that this is a leg, so we can label that A. And this is a leg, we can label it B. And since this is the longest side, it is the opposite of the right angle. This is C. Now they've used that information, and you can see right here, if you need to pause the video and read through it, you can. They've taken A, plugged in 20. They've taken the 15, plugged it in for B, and C is what we're looking for, so we left it as C. Now they have simplified it. I know you learned this in the last lesson. If you need to, go ahead and pause and read through how they did this. They found that the wire is 25 feet long. Now, one thing I want to make sure you understand is that, remember back here I said A and B can be named interchangeably? What if I had said this was A and this was B? Notice if I put A as 15, remember over here they put 20, and I put B as 20, which is the opposite of what they did here, notice I still get to the same answer. So make sure that as long as you label your hypotenuse C, the other two are interchangeable. Okay, let's go ahead and look at number 1. In the example, how do you know which sides are the legs and which side is the hypotenuse? I think I just went over that. See if you can write that down for yourself first. If you need to, pause the video. Now, what you'll notice is the legs. Now, I'm not going to write in complete sentences just so this isn't a really long video, but the legs, they are touching the right angle. That's how I know the legs. And I know the hypotenuse. That is opposite the right angle. And I also know that it's the longest line, the longest side. So those are the things that I think about when I know, or when I need to figure out which ones are the legs and which ones are the hypotenuse. Okay, now let's look at number 2. Number 2, I'm noticing I'm going to zoom in a little bit here. Number 2 says, are the side lengths of the triangle in the example a Pythagorean triple? Okay, so are they a Pythagorean triple? Let's go ahead and write down what were the 3 sides that they came up with. They said 15, then they had a 20, and then we found out the hypotenuse was 25. So let's use our little picture here. If this is a 15, this is a 20, this is a 25. Is it one of these Pythagorean triples? Take a look. What do you notice? Okay, so I notice that these are all multiples of 5. So how many times does 5 go into 15? 3 times. How many times does 5 go into 20? 4 times. How many times does 5 go into 25? 5. What do you notice is our Pythagorean triple? Notice that we've used 3, 4, 5 as the side lengths, but then we've multiplied all the digits by 5. So if I wanted to, I could have actually looked in this picture and went, this is 3 times 5. This is 4 times 5. So that means C must be 5 times 5, which is 25. I would have saved myself all this work had I stopped and looked for that pattern first. So that's how we use Pythagorean triples. Okay, let's go ahead and turn the paper over. Number 3, find the length of diagonal AC in the rectangle at the right. Okay, find the length of diagonal. Diagonal means it's going sideways. I'm looking for A to C. Now, there's a couple of really neat things that I notice about my picture here. This is on a coordinate plane. So because this is on a coordinate plane, these lines are perpendicular to each other. And since they are perpendicular, that's just the way graph paper is made, this is automatically a right angle right here. Automatically a right angle as long as it's on a coordinate plane. So we know this is a right triangle, so we know we can use Pythagorean theorem. So now I'm going to look at, this is A, this is B, and since AC is opposite of my right angle, then I know AC is my, what is it? The hypotenuse. It is C. Okay, so now let's go ahead and write, we have A squared plus B squared equals C squared. Let's plug in what we know. What is A? 10 squared. What is B? 24 squared equals C squared. Now, I'm going to stop for a minute and look at my Pythagorean triples. Is there something in here that I could use as my Pythagorean triple to make my work easier? Which one do you notice? We have a 10 for an A and 24 for B. Do you notice that anywhere? Does it look like one of my patterns? Yes, it looks like the 5, 12, 13. So notice that even in my example on my postcard, I took 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. So this is really cool. I don't have to do all of that math work. I automatically know that because this is 10 and B is 24, my C is automatically 26, right? C equals 26. So that is how we can actually use Pythagorean triples to make our work a little bit simpler. I always joke that mathematicians like to be lazy. We find patterns and we use those patterns to make our work easier. Okay, let's go ahead and look at number 4. Number 4. The bottom of a 30-foot ladder is 7.5 feet from the bottom of the wall of a building. Oh my gosh, that was a lot of words. Okay, the bottom of a 30-foot ladder. I'm going to check that. Bottom of a 30-foot ladder. Okay, so what they're telling us is this is the ladder. I had to look at that. Okay, so our ladder is leaning against the wall, and it's 30 feet tall. It is 7.5 feet from the bottom of the wall of the building. Okay, so the bottom of the ladder is 7.5 feet away from the wall. Explain how you can find the height at which the ladder touches the wall. So we want to know this. Then find the height to the nearest foot. Okay, so with this information, let's go ahead and start labeling. Remember, I always said we want to read it at least twice, and then we want to label. They've already drawn the picture, and they've put some of the labels in, but we need to figure out where do our A, B, and C go? Okay, so A and B, those are our legs. Which numbers are the legs? Okay, we can use A here. Notice we don't know A. And then our other leg is B. How did you know those were the legs? Remember, here is our right angle, and our legs are the ones touching the right angle. Then where is our hypotenuse? What is C? Right, this is C. Oops, there we go. This is C because it is opposite of the right angle, and it is the longest length in our picture. So let's go ahead and substitute our numbers in. A, we don't know, so we can just leave that as A squared. B is 7.5, and C is 30 squared. Okay, I realize I do not have my calculator. If you have a calculator, you're welcome to figure out your numbers here. 7.5 times 7.5. I wish I'm maybe a mathematician, but I'm not super fast at numbers. So let's do this real quick. 5 times 5 is 25, 35, 36, 37, 35, 49, 50, 51, 52. Okay, 12, 6, 5, 2 decimal points. Okay, so I'm at 56.25. Okay, and then 30 times 30. Well, I know that 3 times 3 is 9, and then I have 2 zeros, 2 powers of 10. Okay, so now how do I figure out A? So remember, this is just solving a one-step equation. So I'm going to subtract 56 and 25 hundredths minus 56 and 25 hundredths. I hope you have a calculator for this because as long as you get the math right, you're good. Okay, 10, 9. Yeah, this gets kind of challenging, isn't it? Lots of work. I will grab my calculator next time. 10 minus 5 is 5, 9, 7, and then 9, 3, 4. Okay. I probably should have just done that in my head. I would have been faster. Okay, so now A squared equals 843 and 75 hundredths. Now I have to find the square root of both numbers. And this is where, if you have your calculator, please go ahead and type that in. Off the top of my head, I don't know this answer. What I was actually thinking about is looking to see if any of them are close. But I don't think any of them are close, not with a 30. Okay, so go ahead and find that answer. I think you can do that one on your own. And let me know if you have any problems with that. I know it's going to be something a little bit less than 30, but not less than 30. Or not more than 30. There we go. Okay, how about number 5? Let's go ahead and look at number 5, a scalene right triangle. Okay, we've got to know what scalene mean. What does scalene mean? Scalene. Scalene means 3 different side lengths. Different side lengths. So your right triangle has to have a short side, a medium side, and a long side. So what that means is all 3 sides are different. So it's going to look something like this. So a scalene right triangle. So it does tell us it's a right triangle. So we're welcome to put that little triangle sign in. A scalene right triangle has a hypotenuse with a length of 50 centimeters. Okay, where does the 50 centimeters go? Where's our hypotenuse? Right, it's opposite. So this is 50 out here, 50 centimeters. The length of one leg is twice the length of the other. Ooh, okay. So we've got A and we've got B. Now we know something here. The length of one leg is twice the length of the other. So what is the one we don't know anything about? We don't know anything about A because we know that B is 2 times A. So what we do is we name A X because that's what we don't know. Now we know that this one is twice the length of A. So if B is twice the length of A, this one is 2X. Does that make sense? I name my unknown X and then I use that to figure out the second side. Okay, so now that we have it labeled, let's go ahead and read what we need to do. What are the lengths of the legs of the triangle to the nearest tenth of a centimeter? Okay, so a squared plus b squared equals c squared. Go ahead and take a minute and plug in what you do know.